Frame interpolation, or the method by which one can generate an in-between frame given a before and after image, has been a long sought-after tool by editors. We wish to produce a deep learning model that can take an input video and perform frame interpolation to produce a high-quality output video with twice the number of frames. Frame interpolation has many potential applications, including doubling the FPS of a video, creating a slow-mo at 50% speed, potentially a compression scheme where one could delete several intermediate frames, transmit the smaller video file, and reconstruct the video at the other end using a frame interpolation model. To implement this model, we had to overcome a couple of challenges fundamental to frame interpolation, as well as those that relate to our dataset. We chose to use our K-pop dance group's 4K cover videos as our training set, as we have over 3 terabytes worth of high-quality dance videos. In comparison with other datasets like YouTube 8M, which may contain many different types of videos like cartoons, video games, and real life, all of our videos are filmed on a moving gimbal with dynamic actors taking up most of the frame, making generalization easier. Since the model that processes 4K cover videos can't fit into GPU RAM, we resized our inputs to 512 by 288. Since the generated frame must be a plausible intermediate frame, we use supervised loss in addition to a generative adversarial network loss.
Here, one can see an overview of our model architecture. We used a unit architecture for both our generator and discriminator so that most of the processing can be done at lower image resolutions, the results of which are upsampled and combined with higher resolution streams. We used 5 videos in our training set and ran the model for 20 epochs on Google Cloud with 2 NVIDIA GPUs.
I can't believe 기다렸던 이런 느낌 나만 듣고 싶은 그녀는 나의 멜로디 하루 종일 꺼내 너를 떠나지 않게 그녀 내 곁에 I can't believe 기다렸던 이런 느낌 나만 듣고 싶은 그녀는 나의 멜로디 하루 종일 꺼내 너를 떠나지 않게 그녀 내 곁에
Overall, our model produced good results in both the GAN and supervised method, as well as the purely supervised model. The peak signal-to-noise ratio of these models were around 22.5 decibels, around 13 decibels below the state-of-the-art. Both models still exhibit overblurring in comparison with real frames where part of a person's body is in focus, but part is in motion. While individual frames can be distinguished real versus fake, our output video is pretty good. 60 frames per second looks like 60 frames per second. Anecdotally, we invited some of our colleagues in our dance group to come and watch the results of the video, and many were surprised to know that our generated videos were 50% generated frames. Many believe that the 60 frames per second videos we produced were actually the original videos we had uploaded to YouTube, but magically made smoother. If this human-level indistinguishability is the goal of many GAN models, we are quite content where we have ended up after 3 months.